Hi students, we have studied about motion. Change in position of an object with respect to the surroundings is called motion. Motion can be represented on a graph. In this section, we are going to study graphical representation of motion. There are two graphs related to motion. First one, distance time graph, and second one, velocity time graph. Then a graph is a line or a curve showing the relationship between two variable quantities, of which one of them changes as a result of change in the other. Then first one, distance time graph. Change in position of an object with time can be represented on a distance time graph. Time is an independent quantity, so it is always taken along x-axis. Every graph has two axes, x and y, and y is the origin. Distance or displacement is represented on y-axis. Then, for uniform motion, we have studied about uniform motion and non-uniform motion. Uniform motion means when an object covers equal distances in equal intervals of time. For uniform motion, we will get a straight line graph. We will get a straight line graph. Listen. O is the origin. Time is taken along x-axis and distance is taken along y-axis. Uniform motion means when an object covers equal distances. Means 1 meter in 1 second, 2 meter in 2 seconds, and 3 meter in 3 seconds, etc. In such type of motion, we will get a straight line graph. Okay. In x-axis, we can take time in seconds, and y-axis, distance is taken in meter. Okay, 1 second, 2 seconds, then 3 seconds, 4 seconds, etc. Next, in y-axis, 1 meter, 2 meter, 3 meter, and 4 meter, etc. If it covers 1 meter in 1 second, 2 meter in 2 seconds, 3 meter in 3 seconds, and 4 meter in 4 seconds, we will get a straight line graph. We will get a straight line graph. We can use the distance time graph to calculate the speed of an object. For uniform motion, we will get a straight line. To do so, okay, we can take any convenient scale. Okay, in x-axis, 1 centimeter is equal to 10 minutes, and in y-axis, 1 centimeter is equal to 10 kilometers. If it covers 10 kilometers in 10 minutes and 20 kilometers in 20 minutes, 30 kilometers in 30 minutes, in every 10 minutes it covers 10 kilometers each. So it is a uniform motion. We will get a straight line graph. Then we can calculate velocity. The slope of the distance time graph gives speed or velocity of the object. Then to do so, we can consider a small portion AB. Then draw two lines. Draw a line parallel to x-axis from point A and draw a line parallel to y-axis from point B and join these two lines. We will get a small portion ABC. Then slope of the distance time graph gives speed or velocity. Speed and velocity literary meanings are same. Speed in a given direction is called velocity. Then slope means change in y-axis divided by change in x-axis. Change in y-axis. y2 minus y1 divided by x2 minus x1. Here in y-axis distance is changing. Then in x-axis time is changing. So distance upon time. Here this one S2 and this one S1. S2 minus S1 divided by this time interval. Okay, this one T1 and T2. T2 minus T1. That is equal to velocity. Velocity or speed. Speed in a given direction is called velocity. We can also plot distance time graph for an accelerated motion. Acceleration determining speed up. When velocity of an object increases, then we can say that it's an accelerated motion. Here, listen. Distance traveled by a car at regular intervals is given. Time in seconds and distance in meters. Okay, time in seconds, 0 first. Distance covered also 0. In 2 seconds, 1 meter. Then in 4 seconds it covers 4 meters. In 6 seconds, 9 meters. In 8 seconds, 16 meters. And in 10 seconds, 25 meters. We can plot distance time graph. Time is an independent quantity, so it is always taken along x-axis. And distance is in y-axis. Then time in seconds, 2, 4, 6, 8, 10. Then we can take any convenient scale in x-axis. 1 centimeter is equal to in x-axis 1 centimeter is equal to 2 seconds. In y-axis 1 centimeter is equal to 5 meters. Okay, then we can plot a graph. In 2 seconds it covers 1 meter. In 4 seconds it covers 4 meter, and in 6 seconds it covers 9 meter, and in 8 seconds it covers 16 meter, and in 10 seconds it covers 25 meter. We will get a curved graph. For non-uniform motion, we will get a curved graph. For uniform motion, we will get a straight line graph. The variation in velocity for an object moving along a straight line can be represented on a velocity time graph. In velocity time graph, time is taken along x-axis and velocity is taken along y-axis. Time in hours and velocity in meter per second. Then, for uniform motion, velocity remains constant. Then, suppose when an object moves with a velocity of 40 meter per second, then time is going 1 hour, 2 hour, then 3 hour, and 4 hour. Velocity remains constant. We will get a straight line parallel to the x-axis. We have studied velocity is equal to displacement upon time. So displacement is equal to velocity into time. The product of velocity and time gives displacement. To know the distance moved by the car between time t1 and t2, between time t1 and t2, t1 and t2 are two time intervals. Then using this graph, then the velocity of 40 km per hour is represented by the height AC or this AC or BD. Then and the time t2 minus t1 and the time t2 minus t1 is represented by the height AB. Is represented by the height this AB. And so the distance AC into BD. AC into BD. Distance or displacement is denoted by S. Is equal to AC into CD. AC into this distance CD. That's equal to 40 km per hour into CD here T2 minus T1 seconds. No, hour. T1 minus T2 minus T1 hour. That is equal to 40 km into T2 minus T1. That is equal to area of AB, CD. Area of this rectangle gives displacement or the distance in a given direction. For uniformly accelerated motion means velocity changes at a uniform rate, means 5 meter per second. Next second, velocity increases 10 meter per second. In the next second, again increases 15 meter per second, and so on. In such cases, we will get a straight line graph. Here, we can take any convenient scale. 1 centimeter is equal to in x-axis. 1 centimeter is equal to, okay, 1 second. In y-axis, 1 centimeter is equal to 5 meter per second. Velocity is in y-axis, time is in x-axis. Then, if it covers 5 meter per second, if its velocity changes 5 meter per second, 10 meter per second, then in the next second, 15 meter per second, we will get a straight line. Area of this rectangle plus area of this triangle gives displacement. Area enclosed within the velocity time graph gives displacement. For uniformly accelerated motion, velocity changes at a uniform rate. 5 meter per second, then 10 meter per second, 15 meter per second. Velocity changes at a uniform rate. We will get a straight line. And the area enclosed within the velocity time graph gives displacement. This area of rectangle ABCD plus the area of triangle ADE gives displacement. That is AB into area of rectangle is equal to AB into BC plus area of triangle ADE, half BH, half into base here, AD into height here, DE. Then area enclosed within the velocity time graph gives displacement. For non-uniformly accelerated motion, velocity changes at a non-uniform rate. Graph can be of any shape.